Hello, everyone. My name is Oriol Pujoldevall, and I'm the business development lead at EnergyWeb. And I'm here today to speak about the work our organization is doing to bridge the gap between blockchain and the potential that can generate in a cross-industry way and the energy industry. So once again, thanks for having us, and let's delve into it. Maybe just a quick word about what EnergyWeb is. EnergyWeb was launched in 2017 as an international non-profit organization that had a simple objective. And that objective was to understand whether blockchain technology would really bring value to the energy industry. In 2017, that was done in an exploratory way. What it shaped into being is a strong mission to develop and deploy an open source operating system in support of a low carbon energy future. We started as a joint venture funded by two organizations. One was a big known nonprofit in the United States called the Rocky Mountain Institute. And the other one was a startup based in Austria called Grid Singularity, coming from the blockchain space. So since the very beginning, EnergyWeb sits at the intersection between energy and decentralized technologies. Through our journey, since 2017 up until now and into the future, one of the core values of EnergyWeb is that everything we produce, everything we do is free and it's open source. So we want our solutions to help keep accelerating the energy transition, helping other companies leverage the work and solutions that we've done to build their own solutions on the space. What we are doing, solutions with this background, is working with pretty much every single type of energy market participant out there, but specifically with grid operators, asset manufacturers, and other key players in bringing devices, renewable energy devices to the grid to build these solutions. So here in this slide, you could see some of the companies that are working in adopting our solutions. Again, leveraging all the EnergyWeb technology stack to build commercial solutions that run on our infrastructure. If I were to frame the situation or the problematic that kind of gives a stepping stone to our project, is essentially something that the energy sector is going through, which is the reality that the investment that is being poured into our grids that traditionally came on a very, very one-sided way from the utilities is said to be eclipsed by the investment coming from the customers, right? If we look at the assets that on a yearly basis are being installed and connected to the grids, the situation is changing dramatically in the sense that storage, smart loads, EVs, renewables are being more and more installed in a small scale distributed way, hosted and owned by customers, but not in a centralized, more traditional way by utilities. Of course, this generates a tremendous potential, right? All these assets come into the energy sector with a lot of flexible potential, but it generates some challenges in terms of how do we make sure that this potential is leveraged? How do we integrate and enable all these assets to participate in the very energy market where they can actually add their grain of sand to the resilience and operation of energy grids? So if we imagine all these devices, again, coming into operation and participating in these markets, the paradigm in which our energy systems are structured changes completely. We are moving from a situation in which we could call the 20th century model grid, in which there's a centralized top-down approach in which the only relationship between the consumer and the utility, or the generator, the retailer in this case, it's a unilateral relationship of a certain amount of kilowatt hours for a certain price at the end of the month. We are moving into a new model in which all these assets interact with the grid real time, have their monetization opportunities, can provide services to the grid, and therefore it's completely decentralized. It's what we boldly call the EnergyWeb model. So what do we need to move from left to right? Well, our response to this is we need an open source digital infrastructure that acts as a middle layer, a connective layer that bridges the physical wall where the customers and the assets inhabit to the market and operation layer, where these entities run energy markets where these devices could participate. The way we see the setup, that of course in the market layer, regulators have to set the high-level rules for engagement, right? What kind of rules and codes of conduct the participants need to abide to. And then grid operators, of course, run the markets and the programs that allow these devices to provide services. On the lower layer, customer and asset layer, customers, the role is investing in assets and defining operational constraints, right? What is the technical capacity of my device to provide services to the grid? And then OEMs, equipment manufacturers, aggregators, retailers, and customers use these assets to participate in markets and these programs that the grid operators have set up. So where does Energy Web and its technology stack come into play in this setup? Again, creating the digital infrastructure that allows these two worlds to communicate. How do we do that? By establishing identities that can represent all the assets, but all the entities as well. Permissions, right? Rules that allow certain assets to provide certain services to markets. And then relationships between assets, customers, and market participants. When I say relationships in the broader term, for example, ownership, like defining who owns each device, who has the right of accessing what data, which also poses advantages in terms of data ownership. It's a very hot topic nowadays. So if we abstract a bit from this concept and we look into what kind of companies fit in these categories, and later on I will speak a bit more about the concrete work that Energy Web is doing in some of these areas. Again, in the bottom layer, we see companies that produce devices that will be the kind of the vector that will provide these services to the grid. For example, car companies such as Tesla. In the upper layer, we have grid operators, California ISO, like PG&E, other transmission and distribution utilities that are the ones running the market on which these devices can participate. If we look at this from a more technical perspective, how is this structured? Well, again, as I said, everything Energy Web does is free and open source. But if we look into it, the way it's really structured is this. First, we have a trust layer where say we leverage the inherent capabilities of blockchain to provide an infrastructure upon which these identities, permissions, and later on toolkits and applications can live. And we do that by using the Energy Web chain, which is a blockchain completely independent from others that Energy Web has developed, which uses a protocol called proof of authority, in which the events that need to take place for new blocks of data to be added to the chain does not rely on a mindless competition among miners to see who has the strongest hardware, but rather on certain pre-authorized nodes that hold what we call reputation or authority in the network to vouch for its right to carry out that role in the chain. In the Energy Web chain, these validators, these authorities, are precisely the energy companies that work with us. But when I say energy companies, again, I include grid operators, generators, distributors, transmitters, also developers and startups that are working on building applications to life, all of them cooperating to make sure that this infrastructure is safe and stable. On top of this infrastructure, what we see here in the toolkit layer is where we find the technology stack that Energy Web has developed that allows both Energy Web and other parties to build full commercial solutions. I will speak a bit more about this in the following slides. But here is where Energy Web has developed what we could call white-labeled pieces of software that kind of comprehend a huge part of development that, if not leveraged, other companies would have to tackle on their own. They can just reuse what is already there and, let's say, build the last integration with their systems or the last mile to market, and you can have a fully functioning product in weeks or maybe months rather than years of having to be invested in this. On top of the toolkit layer, again, what we have is the app layer, where the real commercial applications live. And are these applications that leverage the toolkits and the blockchain to provide real commercial value to them. So again, one step back and let's look at how this actually works. I spoke about us providing identities and establishing relationships between assets, customers, entities. What we see here in this slide is a graphic representation on how an identity for an asset or for a user would look like. We assign these identities using something called DIDs, decentralized identifiers. And essentially what the DID is as a persistent, tamper-proof identity. It's a digital passport that gives us all the information that we need to know from an asset to determine the capacity of that asset to provide a certain service to the grid. What we see here in this slide would be the graphic representation of a passport of a battery that has been installed in a residential house, in this case, the Jones residence. And as you see here, it's identified as an energy storage system. So what kind of information do we need from that battery? Well, as you see here, we need the asset type, in this case would be a battery, the location, where is it physically deployed, the model, the capacity, and how much flexibility can it provide if needed, the energy, how much energy that battery is containing at any time, and the RAM rate, right? How fast can that battery react if I request that it delivers services to the grid? Well, this information is crucial because it will be directly the decisive factor to kind of make a judgment on whether if that battery is accepted or not into certain markets. And we see here on the right, there's a section with the wholesale market and the distribution market. Because of that information on the left complies with the entry requirements that the market operator has set on the right, this battery has been accepted into the energy wholesale market, ancillary services can provide to the grid. And then in the distribution market can help is critical peak rate and can act as a virtual power plant. So that is directly impacted by the technical capabilities of the battery to provide services with a quality or a degree of say, performance that markets require. This was for a battery. If we, again, take a step back and look at it from the Eagle perspective, we can do that with every single asset, every single customer or entity that interacts with the grid. What we see here is a battery that has been digitized, but also an EV, solar panel, solar farm, a normal, regular user, owner of an asset, and a smart building. Once these digital identities have been authenticated and therefore recognized by the blockchain, is when they automatically can start self-registering into markets where they can attempt to participate. If we follow the lines, uniting the two middle columns, we see that the battery, for example, has been accepted into the TSO application registry and the DSO application registry, meaning that any app that is connected to these registries, essentially are authorized portfolios that the TSO or the DSO are running, any app that is connected to that will be able to leverage that battery to draw services from it. And vice versa. The battery will be able to leverage that app to monetize their flexible capacity and interact with the market that is connected to that application registry. The way all this is structured, the way these identities and permissions are managed, is via Switchboard, which is an open source identity and access management tool that EnergyWeb has developed. It essentially provides value from two different perspectives. For DID owners, it allows them to create digital identities and owning and controlling them independently using a UI that EnergyWeb has developed. It also allows to manage the core identity and associated verified claims. The verified claims, again, is these pieces of information, RAM rate, energy, and so forth, that allows us to determine the potential of a certain asset to participate in a market. And then finally, via Switchboard, they can manage the assets and the enrollment of these assets into different applications. So they can control in which markets their assets are trying or are actually participating in. From the perspective of application developers, it helps them define the user roles for an app and the permissions. So in this case, we are at the other side of the fence. We are defining entry conditions that devices will need to comply with in order to be accepted. Application developers via Switchboard can also define the claims, right, that assets need to prove in order to be accepted into those markets. And it allows application developers to literally authorize or deny the access of these devices into the markets. They can also manage user enrollments by checking that the right verifiable claims are in place and log all the operations that are taking place with their application. If now we see at what this technology is being used for, Energy Web and its member organizations are now working into what we could call 3 big blocks or 3 big areas in bringing these solutions to market. The first is traceability, is making sure that this ability to provide digital identities and control the information coming from each device helps us keep track and prove the origin of energy that is being generated. So that allows us to register any generation device and keep track of all the readings, the energy output that device is generating. But not only keeping track of it, we can literally digitize the green attributes of that energy that is being generated and even put it into a marketplace where corporate buyers or even private buyers can acquire these certificates, therefore furthering their sustainability targets. Another big area, it's the asset integration. It's using this system to assign digital identities and permissions of access to markets to actually bring DERs, distributed energy resources, into flexibility markets. And Energy Web is working with grid operators across 5 continents to set up systems that allow them to leverage the unexploited flexible capacity in their networks to be able to control these devices or to let's say, tap into their potential and draw flexibility from it. And that is done via an application that is built on one of these toolkits called Energy Web Flex. And finally, another big area is what we call asset management. So it's using this ability to have digital identities constantly providing information about the life and the events that an asset goes through to precisely come up with a tracking system that allows the responsible entities in every market to retire assets once they are at the end of their life cycle, to essentially leverage these digital identities to know exactly when that happens. Of course, that's just one of the uses for this technology, but it enables essentially supply chain visibility, and it sets a system up that it's quicker, low cost, and allows for the settlement and audit of the state of these devices in a much more efficient way. If we look at where this is actually happening, we see here in the slide, there's several projects that Energy Web is involved in as of now in bringing these pieces of software into life, into fully commercial solutions. So in North America, Energy Web is working with the California ISO, with PG&M and NV Energy. In Central America, with Mercados Eléctricos, South America, Electrobras, Nute. In Europe, we are working with the Elia Group, Elia 50 Hertz transmission, BBAT, Electrical Dense in Catalonia, Austrian Power Grid, Vestas, Stedin, SP Group, PTT, SB Energy in Asia, are examples of companies that are leveraging all this technology stack to scale it and build their own solutions that run on the Energy Web infrastructure. And of course, we are extremely excited about the adoption that this is having, but more excited even about what this will bring in the next couple of years. I hope this was an insightful presentation about what this work that Energy Web is doing in the energy and decentralized tech space is doing, the fruits that it's giving. I'd be extremely happy to take this discussion offline or even during the event. Here you have my name and my email. again, I'd be very happy to discuss opportunities like this with any of the attendees. So thank you so much again for having us, and have a great day. Enjoy the event.